Let's try to solve another Leetcode problem 900 RLE Iterator. So for this problem, we can use our round length encoding. So it is called RLE. So the round length encoding, let's just check this example. So we have 38 and 25. So the encoding is going to be 3825. But actually, we are just giving this kind of encoding array. And the encoding can also be 380925. This means there's going to be zero. The number of 9 is going to be 0. Yeah. And then, so for example, we also have the encoding like 2818. Yeah, we also have 38, but we have different encodings, and we have 25. So we have many kind of encodings. Definitely, there are going to be duplicate encodings, but it is okay. So, giving a round length encoding array, design an iterator that iterates through it. So implement this kind of a class. So the classes we are giving an encoding array. And the next method is that we're going to exhaust the next element and return the last element exhausted in this way. Yeah, so if there's no element, we're going to return a -1 instead. Maybe you still don't understand the problem, but let's just check an example. Now you should understand it. So let's just use this example. So we are giving this kind of array. It means 3809 and 25. So it's going to map to a sequence. But yeah, let's just check this kind of a sequence. But we cannot solve the problem by using a sequence. And because the encoding length is even, this is okay. The encoding length is 1000, this is okay. But the number of n going to be 10 to the power of 9. And encoding I going to be 10 to the power of 9. So this means why we cannot prepare an encoding like this. Otherwise, it's going to be time limit exceeded. Because it may be they're going to be 10 to the power of 98. And the number of 5 may be 10 to the power of 9. Definitely, we cannot solve it like this. But we can use this way to understand the problem. Yeah. Now we're going to check the next 2. So after 2, 8. So the next 2 going to be 8. Yeah. So what's left behind is 8, 5, and 5. So this is currently what we have. And then we're going to check the next one. So we're going to return an 8, and we're going to take out this 8. And what's left behind is 5 and 5. Now we're going to check the next one. So we're going to get a 5, and what's left behind is only 5. Now we have the next 2. Because there's only one number, we can take out one number, but there's nothing left behind. So we need to exhaust 2 terms, but there's only one item. So this means we're going to return a -1. So this is because the first term exhausted was 5, but the second term did not exist. If it did not exist, so we're going to return a -1. Now I think we should understand the problem. Now we just need to think of a way to solve the problem. Definitely we cannot turn such problem into a sequence like 8855 because it's going to be time limit exceeded. But we can directly use those encoding numbers directly. So if there's a 9, if there's a 0 like 09, we don't need it. Yeah. So first of all, we're going to turn this array. I would like to use a queue because the queue is enough to solve the problem. I just prepare the tuples. Let me just copy the array to explain what kind of method am I going to use to solve the problem. Yeah. So there's going to be 09. It is okay. So I don't need it. So I want to prepare a queue, and inside the queue there's going to be a tuple. So I'm going to put 38 inside as a tuple. And then, because there's going to be 09, so the number of 9 is going to be 0, so I don't need to put it inside because it has no influence. Yeah. Now I need to put 2 and 5. So this means for the this number 5, I have 2 times, and for this number 8, I have 3 times. So it means the number of 8 is going to be 3, and the number of 5 is going to be 2. But I need to have such kind of sequence. So if I need to have a sequence, this means I normally I would like to use it as a queue or stack, but the queue is better for such kind of problem because we just need to pop it from the left side, and we're going to check how many 8. Yeah, because currently if the next is 2, it means we have 3 8. It is okay. We just need to pop it out from the left side and pop it in. So first of all, we're going to check as this 3 is more than 2. So what are we going to do? We're going to return an 8 because definitely the last item is going to be 8. Yeah, so we first pop it out. Yeah, now we need to pop it in from the left side. So the 3 minus 2 is going to be 1, so we're going to pop 1 and 8 inside of the queue. Normally it's going to be at the head of the queue, and then we're going to check the next one. So the next one going to be 1. Because this number is 1, it is okay. So we just need to return L8, and we're going to pop this one out. Yeah. And then we're going to check the next one. It's going to be 1. As 1 is less than 2, so we're going to pop this out and pop it in. It's going to be 1 and 5, and we're going to return a 5. And now we have a number 2. So for this 2, but we only have 1 5. It means it is not enough, so we're going to return a -1. So this is the simulation why we can solve the problem by using a queue. Now let me just prepare it. So we're going to prepare a queue. It's going to be the queue. Yeah, it's going to be an empty queue. Now I want to check that. So for I in range from 0 to the length of the encoding, and I'm going to have a step of 2. Yeah. Now I want to put the tuple inside the queue. So I'm going to append it, the encoding. Yeah, actually, yeah, let me just use this way. Encoding 0, encoding I, and encoding I plus 1, the next element. So normally I put 38 inside, but I need to check. I don't want to put 09 inside, so I need to check because there's no meaning for the comparison, because at least I should have some numbers, but it is 09. There's no meaning for this kind of encoding for me to solve the problem. So I'm going to have a check. So if the encoding I equal to 0, not equal to 0, I want to put it inside. Yeah. If encoding I not equal to 0, I want to put the encoding I and I plus 1 as a tuple inside the queue. Now let me check what is inside the queue. You're going to understand why. Let me just return a random number n. Yeah, so now let's just check what is inside. It's going to be 38, 25. It means everything should be okay for us to solve the problem. Yeah, now let's just continue. Now we're going to use this queue to solve the problem. So I'm going to prepare a result as infinity, and I'm going to return the result if this result not equal to infinity. Otherwise, I'm going to return a -1. And let me later on explain why I'm going to return such kind of a formula if it is not equal to infinity. Because later on, we're going to update this result. If there's a possible result, definitely we're going to update it. If there's no possible result, so this result is going to be infinity. But our final result is going to be a -1 if there's no possible result. So that is why I designed it like this. Now I'm going to check the queue. So let's just check the queue, while self.queue. So we're going to pop out the how many numbers and value. So the number going to be 3 and the value going to be 8 for the first example. So the num and the value going to be equal to q dot pop from the left side. Now we're going to compare the n with the num. Yeah. So if this n, yeah, let me maybe use num. So the num going to be 3. If this is 3 is more than 2, what's going to happen? If num is more than n, yeah, so definitely we need to pop it inside the queue from the left side. Yeah. So queue needed to append a tuple, and going to be num minus n, and another value going to be our current value, and we're going to prepare a result, and it's going to be the current value. It is okay, and we're going to break it. So this is one case. So another case is if this num, yeah, let me check. Maybe the num equal n is also okay, but if num equals to n, it is 0. I don't want to put it inside. So let me just have a check. So if this num equal to n, I want to have another check. Yeah, definitely I don't want to put it inside the queue because num minus n going to be 0. Yeah, so I just want to update the value, so the result going to be equal to the value, and I want to break it. Yeah, so this is the second case, if this num equal to n. So if it is equal, I just need to record the result. It's going to be equal to the value, and it should be okay. But I don't want to put it inside the queue because num minus n gonna be 0, and I just want to break it. And let's just check the third case. So the third case is that this num gonna be less than n. So for the last example, while I'm prepared the last example, for example, so this value maybe the number of 5 gonna be 1, but the next gonna be 2. Yeah, so this is a 1. Yeah, so this is a 1 because we updated, and this is gonna be 2. So this means the num gonna be, so this is the num gonna be less than the number n. So we just wanted to update. Yeah, we just wanted to update the n. Yeah, so from here I think I forgot to update the. Yeah, let me think about it. So from here I want to update the value of n. So n gonna be minus equal to the num. Yeah, if it is equal, I can directly get the result, and I'm gonna break it. If num is more than n, I can directly get the result. Yeah, but the num is less than n. What's gonna happen is I gonna update this n. So currently this n gonna be equal to 1 because n equal to 2. 2 minus 1 is gonna be 1. I'm gonna check the next, but currently the queue is empty. I cannot check, so that is why I'm gonna return a -1. And for such problem, if you don't understand it, you just use the example and put the numbers inside. Definitely, you're gonna understand it. It will not be so difficult to understand. Let me just fix it. I think it's gonna be self.q and self.q. Yeah, now let me just run it. This is something wrong. It's gonna be 8, 5, 8 minus 1. Yeah, let me check what is wrong with it. So first of all, I'm gonna have a 8, and then I should have 8, but I return a 5. Let me check. Yeah, so normally I think I should to print out the num and the value. Let me just print it out to have a check. Yeah, so first of all, I have 3 and 8. It is okay. Now, for the next one, I have 2 and 5. Definitely, it is wrong, because for the next one, I should have 1, 8. Because I consumed 2, and I should have 1, 8, but I have 2, 5. It means definitely it is wrong. Let me check why it is wrong. So, for this case, the num gonna be more than n, and self.q should append and self.q should append the value. It's gonna be 1 and 8. Yeah, I forget to it should append at the left side. That is why I should not append it at the end. That is definitely not right, because what I explained my simulation, that is append to the left. Yeah. Now let me just run it. Now as you can see, it works. Yeah. So sometimes we're gonna make silly mistakes, and we have to be careful about it. Now let me just submit it to check if it works. Now as you can see, it works, and the time complexity for such problem, let me just check, because we are using a queue, so it's going to be on. Yeah, so this is just a queue. We just iterate through the encoding array and put it inside a queue, so that's going to be on. And here, while we are checking the queue, so for each of the time, so for the next checking, if we can find it, we can directly have a return. Otherwise, we're going to use this n minus this num. Yeah. But for each of the time, definitely we pop out one number. Maybe sometime we append a number inside, but it should not be so many cases. Yeah, so actually there gonna be 1000 calls, and this n gonna be 1000. So the time complexity gonna be 1000 times 1000. Yeah, because the initialization is just one time, so this is okay for on 1000. And for this next, because we've already prepared the queue, so for each of the next, so the average time gonna be 1000. The maximum time gonna be 1000. So the time complexity is still gonna be 1000 times 1000. Yeah, because while we are checking this queue, if we didn't find, we're gonna execute this line like many times. So how many times? We are not sure, but definitely it's gonna be like 1000 times. Yeah, so this is gonna be the maximum time. But if there's 1000 times, definitely we popped out all of them. I think the time complexity for average and maximum, the time complexity gonna be on, not on square. On, it means for each time of the next, it's gonna be O1 time. Yeah, even for here, you know, if we pop out all the elements inside this queue, there will be empty, and while we are checking the next, we don't need even to run it. Yeah, so that is why the time complexity should be on, just like this 1000. And for each call of the next, it's gonna be O1, and there will be 1000 calls, so it's gonna still be On. And let me just run it again to check if it can speed up. Normally it should be okay. And if this cutoff speed like 15 milliseconds, normally the time complexity gonna be On. And I think that's for it. Thank you for watching. See you next time.